bytes and byte array operations. Both bytes and byte array objects support common sequence operations. They interpolate not just with operands of the same type but with any bytes like object. Due to this flexibility, they can be freely mixed in operations without causing errors. However, the return type of the result may depend on the order of operands. Note, the methods on bytes and bytes array objects don't accept strings as their arguments, just as the methods on strings don't accept bytes as their arguments. For example, you have to write a is equal to abc, b is b. Let me type in IDE, it will be more elaborate. ABC is equal to A, then B is equal to A dot replace AF. Okay, print B, and let me print output FBC. FBC. Okay, A is replaced by B, and now and A is equal to, this is bytes operation. So bytes and byte array operation. If I say A is equal to B, B equal to binary ABC, and B is equal to A dot replace B, we have to like mention like this, not like strings. That is the difference. Print type B, print output B. Here also let me print type B, print type B, run. First its type was str, and then its types converted to bytes, and this is the bytes array. Some bytes and byte array operations assume the use of ASCII compatible binary formats and hence should be avoided when working with arbitrary binary data. These restrictions are covered below. Note, these ASCII based operations to manipulate binary data that is not stored in ASCII based format may lead to data corruption. The following methods on bytes and byte array objects can be used with arbitrary binary data. These are the same methods that are being supported by string operations. So I'm not going to showcase its examples because it is already covered there. The only difference is that instead of string, everywhere we are using byte object or byte array object. That is the only difference. So you can go to channel and search for string methods, and there are 9 videos that you can go through. The only difference as explained here is just that instead of string arguments, we have to use byte object or byte array object. That is the only difference. So let me go through just all the methods. Bytes dot count sub start end, byte array dot count sub start end. Return the number of non-overlapping occurrences of subsequent sub in the range start end. Optional arguments start and end are interpreted as in slice notation. The subsequence to search for may be any bytes like object or an integer in the range of 0 to 255. If sub is empty, return the number of empty slices between characters, which is the length of the byte object plus 1. Changed in version 3.3. Also accept an integer in the range 0 to 255 as the subsequence. Bytes dot remove prefix, comma, slash. bytes array dot remove prefix comma slash. If the binary data starts with the prefix string, return bytes length prefix colon. Otherwise, return a copy of the original binary data. B. Test hook dot remove prefix b test. Base test case dot remove prefix b test. Like output is this. The prefix may be any bytes like object. Note: the byte array version of this method does not operate in place. It always produces a new object even if no changes were made. Bytes dot remove suffix bytes array dot remove suffix. If the binary data ends with the suffix string and the suffix is not empty, return bytes colon uh, colon minus length suffix. Otherwise, return a copy of the original binary data. B. Misc test dot remove suffix b test. Output will be this. And B. tmpdir mix in dot remove suffix b test. It will return the original string. The suffix may be any bytes like object. Note: the bytes array version of this method does not operate in place. It always produces a new object even if no changes were made. New in version 3.9. Bytes.decode. Encoding is equal to UTF-8. Errors is equal to strict. Byte array dot decode. Encoding is equal to UTF-8, errors is equal to strict. Return the bytes decoded to a string. Encoded defaults to UTF-8. See standard encodings for possible values. Errors controls how decoding errors are handled. If strict, the default, a Unicode error exception is raised. Other possible values are ignore, replace, and any other name registered via codex.register_error. See error handlers for details. For performance reasons, the value of errors is not checked for validity unless a decoding error actually occurs. Python development mode is enabled or a debug build is used. Note: passing the encoding argument to string allows decoding any bytes like object directly without needing to make a temporary bytes or byte array object. Changed in version 3.1 added support for keyword arguments. Changed in version 3.9, the value of the errors argument is now checked in Python development mode and in debug mode. Ends with python.end bytes.ends with suffix start end. Byte array ends with suffix start end. Return true if the binary data ends with the specified suffix, otherwise return false. Suffix can also be a tuple of suffixes to look for, with optional start test beginning at that position, with optional end stop comparing at the position. The suffixes to search for may be any bytes like object. Bytes.find sub start end. Byte array.find sub start end. Return the lowest index in the data where the subsequences sub is found, such that sub is contained in the slice s start end. Optional arguments start and end are interpreted as in slice notation. Return -1 if sub is not found. The subsequence to search for may be any bytes like object or an integer in the range 0 to 255. The find method should be used only if you need to know the position of sub. To check if sub is a substring or not, use the in operator like py in bpython true. Changed in version 3.3 also accept an integer in the range 0 to 255 as the subsequence. Index bytes.index sub start end. Byte array.index sub start end. Like find but raise value error when the subsequence is not found. The subsequence to search for may be any bytes like object or an integer in the range 0 to 255. Changed in version 3.3 also accept an integer in the range 0 to 255 as the subsequence. Bytes.join iterable. Byte array.join iterable. Return a bytes or byte array object which is the concatenation of the binary data sequences in iterable. A type error will be raised if there are any values in iterable that are not bytes like object, including str object. The separator between elements is the contents of the bytes or byte array object providing this method. Static bytes.makeTrans from to. Static byte array.makeTrans from to. This static method returns a translation table usable for bytes.translate that will map each character in from into the character at the same position in to. From and to must both bytes like objects and have the same length. Bytes.partition sep byte array.partition sep. Split the sequence at the first occurrence of sep and return a 3 tuple containing the part before the separator, the separator itself or its binary copy, and the part after the separator. If the separator is not found, return a 3 tuple containing a copy of the original sequence followed by 2 empty bytes or byte array object. The separator to search for may be any bytes like object. Bytes dot replace old new count. Byte array dot replace old new count. Return a copy of the sequence with all occurrences of subsequence old replaced by new. If the optional argument count is given, only the first count occurrences are replaced. The subsequence to search for and its replacement may be any bytes like object. Note: the byte array version of this method does not operate in place. It always produces a new object even if no changes were made. Bytes.rfind sub start end. Bytes array.rfind sub start end. Return the highest index in the sequence where the subsequence sub is found, such that sub is contained within as start end. Optional arguments start and end are interpreted as in slice notation. Return -1 on failure. The subsequence to search for may be any bytes like object or an integer in the range 0 to 255. Changed in version 3.3 also accept an integer in the range 0 to 255 as the subsequence. Thank you.